Hi everyone, welcome to Kubernetes Communities Days in Bangalore 2021, and let's get started. So what I wanted to start today was by paying tribute to folks that we lost recently, Dan Cohn and Piyush Gupta. Dan was instrumental in making CNCF what it is today, and Piyush Gupta was a valued member of the community who passed away recently due to COVID. Please click on the URLs below, basically scan code, the QR code to relive some memories and leave your thoughts there. A little bit about myself. I was born and brought up in India, ended up in Boston. I've been doing open source for a long time. I wear a few hats in the community. I'm employed by VMware and I'm easily reachable on Twitter, Slack, GitHub, etc. So, what are we going to talk about today? So, we're going to talk about a little bit about the big picture. So, and it seems like COVID has definitely taken the world by, has changed life for everybody as we know it. And some of the things that we are seeing is that a lot of growth in SaaS, for example, people moving to public clouds, people trying to use multiple cloud vendors, also edge. The on-premise installation of Kubernetes may be a little bit lower, but overall, I think it's the industry itself has changed quite a lot in the last year. Software is eating the world, and cloud providers are being used like a public utility. We try to pay we try to bring things down when we are done with them, and we pay for what we use. So if you look at the cloud native report from CNCF, the number of people that are developing on Kubernetes, using Kubernetes, is growing by leaps and bounds. The last one is from 2019. For obvious reasons, we didn't run a report last year, but even the last report from 2019 is showing a whole bunch of usage of Kubernetes cloud container orchestration technologies and CNCF projects in general. There is also significant developments happening around serverless active architectures and cloud functions as well. And a whole bunch of serverless users are using things like AWS Lambda as well. Now, what is cloud native? This is the precise definition from CNCF as to what cloud native is. And this basically tells us that people should start rethinking their software development practices and how they approach architecting software and make them run well on public clouds, and not try to design things that are really huge, really big, and can't be decomposed and things like that, right? So I think it's pretty clear that there is a distinction between how we used to do software before and now how we need to do it for it to work well in the cloud environments. So that's basically what we are talking about here. So CNCF has a whole bunch of projects, and we have at least 15 projects that are marked as graduated. One of the anchors of CNCF is definitely Kubernetes. Kubernetes and CNCF projects have a lot of momentum. For example, if you take Kubernetes, OpenTelemetry, Envoy, NATS, KubeVirt, you see significant PRs merged per repository for the last few, starting from for the last week, for example, right? Or even if you can take a longer, even if you take a longer time period, you will see the statistics are strong. In 2020, CNCF TOC actually switched to a new model for accepting projects in the sandbox, and a whole bunch of new projects started joining us. So some of the projects you might recognize, for example, K3S, Kubernetes, and things like that, CNI Genie, Argo, Volcano, are, SMI is a new thing as well that we are trying to see if people are interested in. Dex is important for security, going forward. So there is a lot of momentum building around, not just Kubernetes in general, but cloud native technologies as well. So in terms of graduations, we graduated 5 different projects, and a whole bunch of projects also moved from sandbox into incubation. I was mentioning Argo before, that was one. So we also have observability tools like Thanos and Cortex in the mix. And we do have Kubernetes at the edge with KubeEdge. Falco moved from sandbox to incubation as well. And Falco is really good at, helping us detect things security-wise when things go wrong or when things get hacked. Spiffy, Spire, Contour all have its roles in the Kubernetes ecosystem. Now, what is Kubernetes itself, right? And why are you all here? All of you here are because of Kubernetes, and Kubernetes is used for managing containerized applications, and it helps you spread the containerized applications across multiple hosts, and we can do scaling and deployment and maintenance of things really easily. And it gives you like a platform layer over and above different cloud providers or even on-prem as well. Just looking at some statistics, you can see that Kubernetes mentions have gone up like crazy over the years. On the left bottom is 2015, and the right top is March 2021. So there are swings along the way, but we are doing pretty well. This is media mentions and other things like that. CNCF collects information from different sources and uses that to construct this graph. In terms of contributions from various folks, Google, VMware, Red Hat, Microsoft, IBM, all the people that you expect, Amazon, Intel, SUSE, Apple, Huawei, Alibaba, everybody is there in the ecosystem, and all are collaborating well and trying to get things done in the community. Now, what makes Kubernetes unique? You've heard about declarative APIs. We'll touch base a little bit more about it. And the eventual consistency model is basically what is a game changer here. Plus, don't forget the community. The community is really, we were just talking about how many different companies are invested in it. And it's not just the companies themselves, but people contribute as individuals, and there's a long tail of contributors coming from all over the world, from all geographical locations working on Kubernetes. That is definitely a game changer. The way a Kubernetes community works has been eye-opening as well. Right at the beginning, things got added into the same the big repositories, but over a period of time, we've been able to carve out pieces like the CNI interface for networking, the CRI interface for runtimes, the CSI for the storage, and for the cloud providers, we have the CPIs. So we kind of split things apart and use interfaces to essentially allow people to experiment, enhance in their own repositories on their own time, and not worry about the changes that are happening in Kubernetes itself. So CRDs, aggregated APIs, have had a huge effect in building the ecosystem. You take any of the projects that we were talking about, QNO, Falco, you take any of those projects that we were talking about, all of them end up using CRDs of some sort, because CRDs are the native way to talk to Kubernetes resources using the kubectl command lines, the command line interface, and it makes the CRDs make it really easy for people to not only interact with the custom resources, but also to write code right, operators that work against the CRDs to get things done. It's been battle tested, reliable, scalable, and we've been putting out releases. We are at like 121 and 122 is in progress. So, and don't forget all the alpha, beta, and the release candidates that we've released over a period of time. So there's a huge ecosystem that tests, validates, runs things. So, you can rely on Kubernetes for your own needs as well. So we talked a little bit about the declarative APIs and eventual consistency. Now, so what are we talking about here? So what we are talking about is control loops. So there is this concept of level versus edge based triggering as well. And what we are trying to say here is, you as a user, you want to say, I want something done, right? And then the controller will go look at it and say, what is the current state of the world and what is the state that you want? And if it is same, we are all done. If it's not the same, then what are the things that I need to do to make what you desire happen, right? So that is basically the control loops that are at the heart of everything that we do in Kubernetes. Architecture-wise, we talked about some of this, pluggable things that at the bottom, and we do have the API server on top of it, and then we have things like cron jobs, deployments, pods on top of that, and we do have RBAC and things for governance, and we do have client Go and kubectl and other things to help interact with the API server, and the rest of the ecosystem is built on top. So if the layered architecture makes it really easy to understand, as well as try to figure out like where things belong and how to interact with things. So in terms of the components itself, there's a handful of like 6-7 components that form the heart of the system. We have the API server, controller manager, and kubelet that are really important. And scheduler is used for scheduling the pods. The kubeproxy is kind of an optional thing because there are some CNI providers that offer a replacement for kubeproxy that works as well, as well. And the main thing that Kubernetes is able to do is when you express an intent as a resource, then we end up turning it into things that get scheduled on the node. And the kubelet is the heart of things, running the things on each node. We do store things in etcd, which is our external persistent store. Some people have talked about replacing etcd with other things, and there are projects in the community as well. For example, K3 uses Kine and can work with other storage providers as well. So this is the heart of Kubernetes, these 5-6 processes. If you understand the relationship between these and how they are put together and how everybody talks to API server and then tries to do the things that we talked about earlier in involving control loops, that's basically how Kubernetes works. In terms of the community itself, the community is divided into special interest groups and work groups, and we've had like a really good experience in terms of the number of contributors and the number of SIGs and working groups. And we love having new leaders step up and old leaders making way after providing mentoring. So emeritus basically means that the folks that were running things are stepping down and they are able to groom new people to take over all the things that they were doing. So one important milestone is we crossed 100,000 pull requests in Kubernetes repository. This is a huge milestone. This is probably the second project to cross this milestone. And we also passed the 50,000 contributors mark as well. Now I'm having a little trouble converting it into lakhs, but you can do the math. So then in terms of like coverage, in terms of like conformance testing, how do you know what you're running from a specific vendor supports all the things that you can do with Kubernetes. We have test coverage for like 75% of the API endpoints, and we are rapidly catching up to do full conformance as well. There's lots of sub projects we are adding, and in terms of features that we are adding, what we call Kubernetes enhancements proposals or KEPs, we've been able to graduate like 35 of them. And for this cycle, we've been able to do 66. I think it bumped up to 69. I think. So, and the production readiness review team and other teams are API review team are looking at these KEPs and making sure that they can do the job and we can get them actually released in 122. In terms of 122 features, we were talking about the number of things that are tracked, and we do have this staggered mechanism. We introduce things as alpha, and then when we are satisfied with alpha, we move to beta, and from beta to stable. Now, when things are in beta, they are turned off by default, and when they are in alpha, they are turned off by default. So if there is something that is marked alpha, then if you want to use it, you switch things on in various, Kubernetes components, command lines, for example, API server and kubelet have feature flags that you can turn on. So the way to look at it is, if it's an alpha, then don't rely on it too much. Use it for experimenting and giving feedback to the community. And when it hits beta, you can use it a little bit more, maybe even experiment with it in production. Just be cognizant that things might change a little bit between beta and stable, because alpha to beta, we get a lot of feedback. And when things are turned on by default in beta, then we get even more feedback. And then when you turn stable, then it's like, use it, and we're going to keep it around for quite a while if it works well. There is a deprecation mechanism by which we notify people when things go wrong, or we want to pull things back out and not support it anymore. So we'll talk about it, those kinds of things. We talk a lot about it, things like that in the community as well. So in terms of talking promotion to stable, we have a whole bunch of things, but these are the most important ones that are going from beta to stable. Some of the things that I'm really happy about are the warnings mechanism, especially because people don't read the release notes, and when they're on the kubectl command line, they get the warning saying, hey, you're trying to do something that's going to go away at some point, so go do something to fix it, right? There's several other things that are important here. Support for Windows, auto-scaling APIs, and external credential cloud providers, and I can go on and on about each of these things, but I don't think we have the time. So Watchout. Earlier, we used to do 4 releases a year. Now we're dropping down to 3. There are important things like Docker shim that are getting deprecated. So please stop using Docker as a runtime. We still support Docker images. We just don't support Docker as a runtime in Kubernetes nodes anymore. So switch to Containerd or CRI-O or other runtimes. There's like lots of materials written about it on what is exactly going away and what you need to do and things like that. So hit me up or hit anybody up in Signode to get some information on if you need it. So again, we're talking about betas. When we do promote things to beta to GA, people can still use the beta APIs for some time, but it's been like 6 releases now, and we have like a boatload of things that we are going to kind of remove. So switch to the GA versions of the APIs. It's not that hard. In terms of future experiments, we are experimenting with a whole bunch of new things, and some of the things that I'm really interested in following along. In fact, we had a call on SIG architecture yesterday about KCP, a minimal Kubernetes API server. And the thinking here is like, can you reimagine how we would write distributed system code when we're not talking about like pods and deployments and those kinds of things, but brand new, different fields, right? What would it look like? Can you still use kubectl to control like microwave or whatever, right? So whatever we can come up with. This is very exciting. Thinking about like how we can reuse all the declarative APIs and things like that in a non container ecosystem. So the main thing that I'm really happy about is all the people that I get to work with on a daily basis. Like Madhav helps us out with controller runtime, test infra. Priyanka helps out with Python client. Aditi is working hard on SigNode, and she's written some caps or helping with some caps. Naveed has been helping me in code organization. Homble is working on SIG storage. Shekhar Rajak is been writing a website for the enhancements proposal from scratch. Sladen has been helping with SIG Windows and CI Signal. Sonia is on the release team. Arsh was an intern, and we worked together for 3 weeks on something really interesting that provides a lot of value to us. Divya has been working on the release team. Ayush has been working on SIG storage and CSI drivers. Long has been helping with API and SIG's YAML as well. Rajula has been helping with Contrabex and release. Barun has been helping with test infrastructure. Kunal has been doing an awesome work getting all the students interested in the things that we do in CNCF and spreading the word. Shweta has been working on an E2E framework. Shivani and Ankita have been helping out with cluster API. Rajas has been helping out in different things, and the most recent thing that he was helping out with was S390 results to test for it. Navaran is all over the place: SIG release, API missionary, code organization, contrabacks, you name it, and he's there. Last but not the least, my co-conspirator Nikita has been awesome, and I love working with her. And she's, we talk about all kinds of things all the time, and I love every chance I get to talk to this awesome team. Now, how can you join us? It's not just the people that I showed you the pictures of. We have a whole bunch of more people from all over India who work in the community and who do things in the community. So come join us. We have a channel, Slack channel on Kubernetes Slack in dev, and we try to have fun as well when we are able to get together. These are pre-COVID, so don't worry about it. We are not wearing masks in these. This was probably, when was this? 2019. So the left one was San Diego, and the right one was actually in Bangalore after that. So hope to see you all, and hope to meet you and talk to you. And this presentation, the first link. So hit the first link to get this presentation. You can hit me up on GitHub, Twitter, Slack, and the most important of all, if you want to get started, the last URL has a whole bunch of links, including videos and presentations and hands-on labs and things like that. So don't be shy. It's easy to get started. There is quite a bit of work to be done for us all together, and let's do it together. Thanks a lot.